purpose of this video is to simplify pointers. Let's consider this adding two numbers. The initial code is extremely simple. No pointer here, x and y, you add them, you print them. Nothing to discuss here. Now let's consider the next variant of the same thing. You create two pointer variables, and these pointer variables are supposed to point to x and y, right? Here line number 12 and 13, those pointer variables are made to point to x and y. Then you ask the user to enter it and you add it. Okay, so now let's say this code slightly confuses you, so I have this suggestion for you that you simply execute each line in your mind, drawing the picture on a piece of paper basically. So I will draw a picture. So let's say line number 6 happens. You basically have p underscore x, which is a variable. Pointers are simply variables. They store address of some that. When line number 6 happens, you create a variable with some garbage value. We don't know what the value is because at line number 6 we never initialized it. Okay. Line number 7 we are creating p underscore y, again with some garbage value. Okay. Line number 9 and 10 we are creating x and y, which are integer variables. Fine. Line number 12 we are saying p underscore x is equal to x. What it means is that this pointer is going to point to x. What exactly it means is that let's say this x is stored at 0x100. Of course, typically the address is FFEE B C 9, whatever, some such number, but I am choosing simple number just for the sake of understanding. So the concept is that p underscore x as a integral value, pointer is after all an address. P underscore x, the value of p underscore x is this memory address where x is stored. So this is what it means when we say p underscore x points to x. What it means is that the value of p underscore x is the address of x, the place where x is stored in memory. Okay, so p underscore y also points to y. So now this is my picture, and then when you say scanf into p underscore x, you are really basically saying read at this address. So the value 10, if I enter value 10, it will get entered here. If I enter value 20, it will get entered here and it will be running. So this is nothing big. Maybe you already are clear enough about it, but I suggest this approach. This approach will help you of thinking. This code was simple. Maybe I will not even run and show. You can run and you can clone this and run and see. Let's see the next one, which uses dynamic memory allocation for the same thing. Okay, for the same thing, I have removed x and y now. I have taken care to allocate memory dynamically. So I allocate memory. Okay, now this should not be star 100. Okay, that's a mistake. It should be removed. So it should not be star 100. Imagine this code without this star 100. I was demonstrating something else and I will edit it. Okay, so assume it is malloc size of int. That's all. Read it like that. So I will hide that anyway. So then we are reading into it, and then we are adding the same way, exact same way. Instead of doing p underscore x is equal to ampersand x means address of x, we are doing p underscore x equal to malloc size of int. Ignore this star 100. Okay, so what happens? So we can execute this also in the same manner. Okay, so I will get a new blank sheet and I will start drawing the picture. So line number 6, we get p underscore x, we create a variable and garbage. P underscore y, line number 7, garbage. Line number 9, what we are doing is we are allocating a memory. We allocate a int worth of memory, that means typically 4 or 8 bytes, and we make this pointer point like this. So now this memory basically now this memory is coming from heap because we are doing malloc. Earlier when we were pointing p underscore x to another x statically allocated, that's another x was coming from stack, but now we are taking the storage from heap. That's okay. And we take another storage from heap for y in the line number 10. Okay, and then subsequent code is the same. You are reading two integers, then you add them and you print them. Okay, so this is the picture. Great. So allocating dynamically is also understandable. Let's now see double pointers. Okay, double pointers often confuse people, but I will like to say that double pointer is nothing but a pointer to a pointer, and pointer is a simple thing. Pointer is nothing great. Pointer is just a variable which stores a address. So double pointer is a pointer to pointer. That means it's a simple thing of a simple thing. So two simple things combined together. So never get confused by multiple simple things coming together. It's just a calculation involving multiple steps, but there is nothing complex about it. So let's see the code first before we draw the picture. We have these single variables, single pointers. We have this double pointer variables. So these double pointer have to point to the single pointer. Okay, so I am saying pp, that means pointer to pointer. Double pointer x points to p underscore x. That means it stores the memory location where p underscore x is stored. And then I allocate memory again. I'm sorry, but ignore the star 100 that has come by error. So we allocate space for the p underscore x, p underscore y, just the same way as previous sample code. When we read memory, when we read x and y, we need to say, we earlier said star p underscore x, okay, or rather we said p underscore x. So what is p underscore x? If we say star pp underscore x, that is p underscore x, because pp underscore x is pointing to p underscore x. So when I say star pp underscore x, this is same as p underscore x. Okay, and this expression you can understand as star p underscore x, which will be x. So we are adding that. So that's kind of okay. Let's try to draw a picture. So p underscore x, p underscore y, pointer variables. Now another pp underscore x, which is a pointer to p underscore x. So that means I can pictorially represent it like this, that pp underscore x is pointing here, and pp underscore y in very similar manner is pointing to y. Okay, and then p and line number 12 and 13 you are allocating from heap using malloc, and p underscore x is pointing to 1 storage. Same for y. Okay, then you read values. When you do scanf, basically you want this address, that means the value of p underscore x, that means star pp underscore x. So you can see that when we did scanf, we are doing star pp underscore x. Okay, so star pp underscore x means the content stored in the pointer, so it is p underscore x basically. And star pp underscore x means first we dereference pp underscore x, so we reach here, then we dereference p underscore x, so we get 10 when we do star pp underscore x. So I am not really covering pointers, arrays, double pointers in this short video. I will create more videos. We will see array versus pointers. We will see array of pointers, pointer to array, double array, we will double pointer. This short tutorial is only intended to simplify pointers. It is to demystify them and give you an approach that you can understand them in a clear manner. Let's see little more code. So just analyze this code and tell me, is it correct or not? So if you think a little, this code is likely to crash. It is likely to give segmentation fault because we are writing these characters at address 0. But maybe our thinking is clouded and we are unable to see that. So again, the same approach of drawing picture. So what is happening? PTR is a variable and right now the value is 0. 0 means that it is if this box represents my virtual RAM, virtual memory, it is pointing to the absolute 0 byte. Okay, and hello world, you can understand hello world as a sequence of characters, H E dot 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 W O R L D, this is dot dot dot, and you have slash 0. So there are 12 bytes if you count. Hello 5, word 5, space 11, 11 printable, and 1 slash 0. Now these are copied byte by byte. Assume this is 1 byte, assume. So these are copied byte by byte at this address. At which address? At address 0. Is address 0? Is address 0? Is address 0 valid? Is pointer pointing, PTR pointing to some heap allocated or static allocated valid segment? No, it's pointing to address 0. We write at address 0, likely to crash. So this will crash, right? So let's see further. Now we are up to correcting it. Okay, the first solution about it. First solution is you please allocate memory to store it. You maybe take space of storing worth 200 characters, you copy it, you use it, and ultimately you have to free whatever you malloc, you have to free. So this looks correct. Let's see pictorially what's happening now. So it's, I think, simple. PTR line number 9 creates PTR, which is null. Line number 11 creates malloc and stores that thing. So okay, let me draw this malloc thing as a horizontal sequence of about 200 bytes. Okay, and here it stores. When we say this pointer points here, it means that if the address is 0x10, then exactly you have you are storing. So let me just write, you are storing 0x10 here, that value. Okay, pointer has the value where that data is stored. Okay, so now we have legitimate thing, and hello world is a small 12 byte array of characters. In a way, you are copying it byte by byte here, and it is very legitimate. You have 200 bytes, you are copying in the initial 12 bytes, no error, all good, very clean code. Another solution is you can avoid malloc, you can make it into a statically allocated array which comes from the stack segment, the function frame in the stack segment. So if I have to understand this picture, then what are we really having? So you are having something like this. You have PTR, which is actually an array. How long is that array? That is max length 200 bytes. So pardon the handwriting. And then you have this hello world 12 bytes, and you are copying byte by byte. So great, no problem, it will be all fine. So what I'm suggesting in this quick video is that analyze them in a pictorial way, get the picture clear in your mind, and to get the picture clear in the mind, draw pictures on paper, and then things will be clear. I'll be creating more videos to demystify pointer versus arrays, what happens when we pass array to functions, how they decay to a pointer, array of pointers, pointer to array, double pointers. So these are not complex things. People are scared of them just because they are unable to think in a pictorial simple way. So thank you for your time.